Hi everyone, today we'll talk about authentication and field level authorization in GraphQL. GraphQL allows users to query exactly what they want, which increases risk if malicious users request too much or sensitive data. Unlike REST, there's no fixed route structure, so security must be enforced dynamically. That's why authentication and authorization are crucial. Authentication proves identity usually through credentials like passwords, token, and OAuth. Authorization determines what actions or data the user can access after being authenticated. Both are essential but serve different purposes. Incoming request passes through authentication middleware. If valid user info such as roles or ID is attached to the request context, resolvers access this context to decide if access should be allowed. This model lets you enforce security per field or resolver dynamically. Most modern GraphQL APIs use JWT or OAuth 2 for stateless authentication. Middleware inspects the authorization header and verifies the token. If the token is valid, user data is attached to the context, which is available to resolvers. This is where you inject the authenticated user object. The verify token function should encode the JWT, verify its integrity and expiration, and extract user claims. Resolvers can now use context.user to enforce authorization. Authorization can be implemented at various levels. Operation: can the user run this query? Mutation: type: can the user access this type of object? Field: can the user see or mutate this specific field? Fine grained controls come from field level enforcement. We have two common approaches. Use GraphQL schema directives like OAuth role admin. Put logic inside each resolver function. Context carries user roles, attributes, or permissions to make these checks. This directive says only users with the admin role can access the email field. It provides a declarative readable way to enforce security in the schema. Using a schema directive and apply it during schema creation. This is supported by libraries like Apollo Server and GraphQL tools. We override the field's resolver. Before resolving the field, we check if the user meets the use record role condition. If not, we throw an authentication error. Simple and scalable. Assign each user a role and each resource a record role. Works well when user permissions don't vary much across instances. Roles can be stored in a database or claims in a JWT. User attributes instead of roles. Example, a user from org ID is equal to 123 can only access data for that org. Offers more dynamic control, especially for enterprise multi-tenant apps. Prevent horizontal access. Users should not access data across tenants. Comparing user.org ID to the requested data's org ID enforces this. This avoids leaking data across organizational boundaries. Never trust client input blindly. Always validate tokens server side. Use data masking or omit fields entirely for unauthorized users. Log attempts to access forbidden data. These are potential attacks. Rate limiting helps prevent brute force or enumeration attacks. Secure your GraphQL API like you would a REST API, but go deeper. Use contacts to carry user data. Use resolvers and or directives for fine-grained authorization. Pick or BAC for simplicity. Use ABAC for flexibility.